My day job, as you've heard, is training the next generation of outstanding teachers at the University of Roehampton. Any Roehampton alumni in the room? Oh, so I'd have expected more. Never mind. Happy memories, though? Oh, that's a relief. Good. I should declare an interest before we get very much further. I'm talking about planning. I'm going to draw on the example of writing a scheme of work that I've been involved with over the last 12 months or so, which is the commercial scheme of work from my friends at Rising Stars. They've got the stand there. I'm not here to sell that, but it's my most concrete and recent experience of writing a scheme of work. So I hope you'll forgive me and make the appropriate mental adjustments between his talking to us about how we could do it rather than trying to sell the one he's done earlier. I'd like you, please, to start by just having a chat with the person next to you about what you're trying to do as a school with your curriculum. By that, I do not mean your computing curriculum or even the national curriculum. I mean the whole planned provision of education that you as a school set there in front of your learners. What are your aims for that? What is it you're trying to achieve with what you do in terms of your classroom, your lessons, your timetable, your curriculum? I'll give you a couple of minutes to chat to a friend about that. I'm sorry to interrupt your conversations, but we don't have long enough. Right, I need 1, 2, 3, 4, see if we can get 3 brave volunteers from the room to shout out what they're trying to do with their curriculum. Hands up first, of course, former head teacher here. Anyone? Thank you, at the back there. Nice loud clear voice. Oh, learning is fun. Absolutely. How are you getting on with that? I'm glad to hear it. Somebody else, please. Thank you. That's such a good thing. That really is brilliant, brilliant idea. One more, let's before I put that together through. Thank you. I love learning beyond class. That's such a nice thing to hear. Wouldn't you like that later to be able to well, the Roehampton trainees hate it when I do this sort of thing. We do this think, pair, share stuff, and then on the very next slide, I show them what answer they should have given. This is what you should have said. Your statutory duty as a school in terms of your curriculum is unchanged since the 2002 Act. It's to promote the spiritual, moral, cultural, mental, physical development of pupils at your school and of society. Good luck with the society clause there, but there is a wider purpose to it. And to prepare pupils at your school for the opportunities, responsibilities, experiences of later life. If you're not doing that, you need a conversation with your head teacher fairly urgently, I would suggest, because you're kind of breaking the law. But I hope everybody in the room is doing that. Isn't that what lies at the heart of what you were suggesting about your aims, your purposes for your school's curriculum? These are jolly sensible things, I would suggest. Notice how forward-looking they are. These are about preparing children for their future and ensuring children's development, taking them from where they are to someplace new. The new national curriculum adds another layer on top of that. In the new national curriculum, the Secretary of State, bless him, says that it's there to provide an introduction to the essential knowledge they need to be educated citizens, introduces them to the best that has been thought and said. Matthew Arnold there in this notion of school or education as transmission of culture, the best of our generation passed on to the next generation, helps engender an appreciation of human creativity and achievement. These are not bad things. And of course, schools should in part be about passing on the best of our generation and our forefathers' generation to the next. But you might think that the best way to do this, to prepare them for these opportunities, responsibilities, experiences of later life, is more than merely passing on the best of our generation to the next generation. Given the pace of technological, societal, cultural, environmental change, is it enough to merely have this sort of culture transmitted? Or should we be looking at something which is a little bit more forward-focused? But don't worry. Paragraph 3.2 is your salvation. Paragraph 3.2 assures you that there is time and space in the school day and in each week, term and year to range beyond the national curriculum specifications. You're reassured by that, I hope. Yes? Okay. The Roehampton alumni in the room. Do you remember the lesson plan form? How does this link to the national curriculum? If they let me out more, sorry, if I wasn't doing this sort of thing more as much, and to go out and supervise trainees out in school, I'd say when you get to that bit of the form, you can leave it blank, because Mr. Gove says you can leave it blank. You can go beyond the national curriculum, or just write in paragraph 3.2. Paragraph 3.2 lets you teach the things that you want to teach, or better still, the things they want to learn. Yeah? Yes, you have to teach the national curriculum, unless you opt out and become an academy. But you can teach anything else you want as well. Please hold on to that as we get into the nitty-gritty detail of the computing stuff. So how do you choose? What do you decide to put on your curriculum? What do you leave out? I think William Morris got it right back in 1880 when he talked about the golden rule for your house is don't put anything in it unless you know that it's useful or believe that it's beautiful. Shouldn't it be the same with our curriculum? Include things which you know they're going to find useful, but also things which you believe in your heart of hearts they'll find interesting. And this, I think, is what we tried to do with the new computing program of study. Bob may wish to disagree. You may wish to disagree. You, however, have still got to teach it, even if you do disagree with that. That's, I think, was at the foundation of what we were trying to do with it. So what have we done? Well, this is what you had back in the last days of the previous government. Anybody remember the Rose Review? That lovely diagram with, you know, the bullseye diagram with those 5 children at the center of that. And Jim Rose saying, ICT there at the heart of the curriculum is something essential for learning and life, alongside literacy, alongside numeracy, not as a subject in its own right, but embedded throughout the curriculum. And this was his definition, or possibly his civil servant's definition, of what ICT capability was. Looking at that now, 5 years on, does anything strike you as missing from that? This is not merely a rhetorical question. A couple of things that occur to me as I look at that now. Yes, he talks about understanding in the first sentence, but later on it's all so much about skills of using software, skills of using technology, not about developing an understanding of digital technology. And secondly, where's the creativity? There. Weren't you doing lots of creative work in ICT? I hope so. Shouldn't he have acknowledged that as an essential part of ICT capability? So where do we move on to? Well, the change is nowhere more stark than here, from Jim Rose's ICT capability to the first sentence of the new programs of study. A high-quality computing education equips pupils to use computational thinking and creativity to understand and change the world. If you take one thing away from this session, it's that, please. No reference to coding here. It's far more important than that. This is about understanding the world. But by playing with computer code, by learning how to program a computer, a child develops an understanding of how digital technology, and indeed the world around them, works. That there's something fundamental to reality in this. And the chance to express themselves creativity. Yes, through digital video. Yes, through animation. Yes, if you must, through PowerPoint presentations. But also through the language of code. And that's got to be a good thing. It really has. So hold on to those ideas. Creativity, as I say, we've been doing that well. Computational thinking is a relatively new idea. You know, if you Google or use Google Scholar to track back the term, you get back as far as Jeanette Wing 2006 talking about computational thinking, and not much further back. What we're talking about here is not thinking like a computer, because computers don't think. What we're talking about here is not thinking like a computer scientist, because that takes years of training and practice. We're talking about thinking about problems and systems so that we can get a computer to help us solve them and understand them. And we have a cluster of concepts there about computers being deterministic machines, about being predictable, unless you're running Windows 8, I suppose, about algorithms as step-by-step instructions, about taking a problem and breaking it down into smaller parts. That's got wide applications across the curriculum. That's not just a geeky computing thing. About abstraction, of focusing on what matters and not worrying about the detail or getting somebody else to worry about the detail, and looking for the common patterns of reusing other people's ideas, and then different approaches which we can bring to getting computers to help us solve problems, understand systems, about tinkering with things other people have made, about making things to show to others, this notion of the digital artifact, about testing things and fixing things when they're broken, a bit like your proofreading, about persevering. Coding is the new gaming because it's hard. That's fine. Hard is good. And about collaborating. It's not a solitary experiment. We work with others. The Royal Society report that Bob referred to earlier had this charming diagram right there in the introductory section about ICT bad, damaged goods. I think they were being really more critical of GCSE specifications than your very good work as primary school practitioners. But they recommended rebranding, moving from, if you will, Windscale to Sellafield, or from Marathon to Snickers, and saying, let's call it something new now, let's call it computing, and identifying those three aspects of that. The digital literacy, they took a very narrow definition, I take a much broader definition. Information technology, and then the fundamental principles of computer science. For a couple of the very early drafts for the program study, we didn't call them computer science, IT, and digital literacy. We called them the foundations, the applications, and the implications. And that's still how I'm thinking about these things. The computer science is why it works, how it works, the foundation of the discipline. Application is, can you put that to good effect, solving problems for other people, using software that others have made, using systems other people have built. And then what does this mean for me as a person and for us as a society? Let's take Google search let's take search as an example, just checking. Anybody not use Google as their search engine? You've got to be just a little bit worried about that, you know, if they did use their powers for evil, we'd all have to watch out there. We really would. Okay. So the foundations, how does Google put those results into order? How does it find all of those web pages? That's hard computer science. It's interesting, and the fact that I think relatively few of us understand that is slightly worrying. Okay. But we can use Google search and we can use it effectively. Very rarely do we have to look beyond page one. That's applications, that's IT. And then bigger questions about how much does Google know about me? How much could you find out through looking through my search history? What is Google doing with that information? How does Google do all of this for all of us for free? That's into what I'd call digital literacy, or that implications territory there. And a balanced approach to your computing curriculum should include all three aspects. Just stopping at how Google works, or even just stopping at how do I find something on Google, isn't empowering enough. It's not sufficiently broad or balanced. I'm not going to go through the bullet points in detail. You'll be delighted to learn, but just let me draw your attention to the fact that there's still plenty of IT and digital literacy on there. Key stage one, use technology purposefully to create, organize, store, manipulate, and retrieve digital content. If you can think of an old ICT lesson that you were teaching that's not covered by that bullet point, I'd love to hear from you over coffee today. Recognize common uses of IT beyond school. That's an absolutely fundamental thing. Used to be a big part of the EYFS goals. Now we're bringing it into Key Stage 1. I think for good reason. And then the digital literacy bullet point at the end there. Keeping personal information private. Think about what that actually could mean if you take those words as they stand on the page there. It's worth saying there's no canonical interpretation of these. And then very, very small font for you to cram in lots and lots of bullet points up in Key Stage 2. Again, look at the bullet points towards the end of that list. Select, use, combine a variety of software, including internet services on a range of devices to design and create a range of program systems and content that accomplish given goals, including collecting, analyzing, evaluating, and presenting data and information. Didn't all get it done in one breath, I'm afraid. It's a train wreck of drafting. But can you really say that this is not a balanced curriculum when you've got to cover all of that by the time that they leave Key Stage 2? That's ambitious. That's really ambitious. Much more ambitious, I'd say, than the old ICT curriculum. But we put it there in one bullet point with very little pause for breath in there. And again, the digital literacy statement at the end there about being responsible, about recognizing acceptable and unacceptable. And further digital literacy further up about evaluating digital content. What a crucial skill in a digitally information-rich age. What you have there on those slides are the planning regulations. They don't, Bob's fond of saying that a program of study never taught anybody anything. What you have there is the minimum requirements that your curriculum has to reach. You have to cover these things. You can do more as well. All we're giving you is the planning regs. Your job is to come up with the architect's plan, is to design or buy or adapt the scheme of work which puts those building regulations into practice, or at least which creates a curriculum that complies with the building regs. And this is a tremendously creative, interesting process, far more interesting than the stuff which Bob and I got involved with, sitting around conference tables and drawing up notes. If only they'd let us loose on putting together a scheme of work about how you're going to do these things in the classroom. You get to do that fun bit. David Brown, who's the national lead for still ICT at our friends at Ofsted, has this when it comes slide which he shows when talking about evaluating schools' curriculum, including their ICT now computing provision. All they check is it broad and balanced in the context of the school? Does it meet the needs, aptitudes, and interests of your pupils? If it's not doing that, then of course Ofsted are going to complain, but I bet your pupils will have complained before that. Their parents will have complained. Does it promote high levels of achievement and good behavior? Is it effectively planned and taught? That's your touchstone. But does our curriculum do what it should? Yes. So yes, you start with the building regs, but then you design something which hopefully will meet those expectations. Bob said that we're not expecting subject survey visits over the next couple of years. If there were, these are the criteria which they're currently using, or they would currently be using, sorry, strange tense involved, if they were inspecting ICT at the moment. The list is a really good, sensible one. Again, once you've got your scheme of work in place, use this as a test of, is it an outstanding curriculum? Is it imaginative? Is it stimulating? Is it designed to match the range of pupils' needs and ensure continuity and progression? Are the contexts relevant to pupils' lives? With ICT, that wasn't too bad a box to tick. You could imagine some approaches to teaching some of that tricky computer science stuff and some of the programming that made that very irrelevant to pupils' lives. And I think you would be rightly criticized by Ofsted if they came in and saw that. So do aim for outstanding when putting one of these together. But for September, minimum viable product, yeah? Get something that works, then tweak, then improve that as you go. Dan's already spoken about the ICT mark. Part of the ICT mark criteria is about the school's curriculum in terms of ICT as well as computing as will be. Is there challenge at all levels? The all level stuff is interesting and significant. We find it easy, perhaps, to challenge our gifted and talented. But the challenge should be for all. And those on the circle table, too, should be stretched, should be challenged. Putting them on the circle table may not be the best possible thing you can do. Is there creative use? Is it comprehensive? Is it innovative? And how do you keep it being innovative? Well, use the Twitter. Use the professional networks to see what is the cutting-edge practice elsewhere. Is there development across the curriculum? Does it ensure continuity? And, importantly, is it safety? So, there are a number of decisions facing you when it comes to deciding how to go about constructing these architect's plans, your scheme of work for how to implement the program of study. Firstly, are you going to go for a discrete, timetabled computing lesson there in the computer lab, or do you want to go for something which is much more an embedded approach? With the old ICT, embedding ICT across the curriculum was definitely the way we were heading. That was Jim Rose's recommendations. I think you can do that brilliantly when it comes to some of the computer science bits too. One of the projects I'm working on at the moment, Barefoot Computing for British Computer Society, what we're looking at is the context elsewhere on the new national curriculum where there are links to computing. A couple of units we've been working on at the moment. They're in year 3 and 4 of the maths curriculum about telling the time. What better way for a child to learn about the relationship between seconds, minutes, and hours than to build their own clock? Doing that with cogs and gears and things over in design technology, very tricky. Doing that in Scratch over in a computing lesson, so many opportunities to really understand how a clock works. And lots of the computer science ideas come in there as well. Somewhere up in year 5 and year 6 of the English curriculum about how structure of a document helps understanding. That's what HTML does. The HTML, the language of the web, marks off the structure of the document. It says this is a paragraph, this is an ordered list, this is a numbered list, this is a heading. And so you can look behind the screen on a web browser and see the structure of the text there. Or reverse the process and start writing with that structure marked off as you're marking up, this is a paragraph, this is the end of a paragraph, this is a link, this is the end of a link. So lots and lots of opportunities for an embedded approach to computing if you wish. Waterfall versus Agile I'll talk about in a moment. National Curriculum or National Curriculum Plus. Remember paragraph 3.2. Feel free to range beyond the minimum requirements. I'd really encourage you to do that. That's what we've done with Switched On Computing. Switched On Computing, sorry, not an advert. We've got a lovely unit in there about understanding cryptography. Yes, it links to the program study, but there's no requirement on the Key Stage 2 program study to learn about how cryptography, code ciphers, that sort of thing, works. Really interesting piece of work. And then, you know, there are other examples. Let me move on. Do you start by planning from the program of study, or do you start with the projects that you want to do? A thematic approach, an approach linked to the rest of your school's curriculum, might have much to commend it. It really might. Look at the cross-curricular opportunities and link that back to the program of study. And again, with Switched On, yes, we've covered the program of study, but we didn't start with the program of study. We started with, this is going to be a really interesting half-terms unit of work. Over the course of a key stage, have we covered all of the requirements on the program of study? You can do the same. It isn't rocket science, not even computer science to do that. Do you adopt something somebody else has made, local authority, commercial publisher, or do you adapt what's there? And I really would encourage you to take the latter of those two options there. Make it your own. Evolution and revolution I'm going to talk about in a moment as well. So Bob says, let's throw out the baby with the bathwater, or he worries that we have thrown out the baby with the bathwater. I mentioned this at one of those interesting roundtable conversations one has, and I was challenged on this by somebody who said, which is the baby, which is the bathwater? If you stop and think about it for a moment, what on the old curriculum do we no longer have to teach on the new curriculum? Is there anything now which no longer is required of us? Well, the reference to email somewhere in Key Stage 2, okay, it's implied rather than required. But there's nothing, as far as I can see, there's nothing that we did teach which is no longer relevant to the new program of study. Yes, there's new stuff gone in there, but I don't think there's very much at all of the old stuff that's been taken away. So all of the lovely things that you were doing, feel free to carry on doing. You're going to need to find some time to teach some new stuff as well, but the best of your units in the past, keep those there on your scheme of work. They worked. There's no need to start all over again. So looking just through the Key Stage 1 curriculum, the green stuff here is the stuff that's new. And yes, there is more, not so much programming. Programming was there on Key Stage 1, but there's more of this computational thinking gone in at the top there. But there's also the e-safety stuff come in as part of what I call digital literacy there at the bottom of the list. I'd hope that you want to start teaching that if you've not been teaching it already. Similar sort of thing happens with Key Stage 2. Yeah? Yes, the programming continues from the old curriculum. It becomes more of a focus, but we add on much more about thinking about programming rather than just the craft of coding. We also get some really interesting extensions to the IT side of this, to the application side. So look, we've got including internet services. We've got on a range of devices there. We've got building systems, which was never part of our expectations at Key Stage 2 in the past. So they've strengthened the IT side and really beefed up the digital literacy side because you've got all of this now safe and responsible use being added in. So yes, there is more computer science than there was, but there's also more IT and there's also more digital literacy than there was. Waterfall versus Agile. Okay, so anybody experienced teaching up in secondary school, A-level computing, A-level ICT? That's a relief. I can get away with this next. In that case, okay. So on the current A-level specifications, they have this model of software development. You start with the person saying, software should do this. Then a team of people, highly paid systems architects, get the job of designing that. Other people, typically wearing t-shirts, have the job of implementing that code. Then we need to test that it's worked. Then we need to make sure that it keeps working into the future. Does that not sound vaguely similar to the way we go about curriculum development? Secretary of State or Minister for Schools says, children should learn to code. Other people, sitting around rather nice conference tables at the Royal Academy of Engineering, have the job of designing a program study for that. You have the job of implementing that in your schools. Of course we're going to do testing, but we're also perhaps going to need to send out the maintenance packs and make sure that it's ticking over properly. We know this works incredibly well for big public sector procurement like the NHS database. Never mind, so it's bound to work okay for curriculum design as well. There are other approaches. Okay, so back in the late 90s, I guess, the Agile development crowd spotted that the things on the left there were fine, they were important, but actually it's the things on the right which were much more interesting and much more effective when it comes to software development, about being responsive to change, about collaborating with customers, we'd call them pupils, about having working software, we'd call it working knowledge, and about focusing on individuals and interactions. Could you please put your hand up if you came into teaching because you were excited about the things on the left-hand side of that slide? Okay, what about if it's the things on the right-hand side that excited you about teaching, or they're analog? I'd hope so. I really would hope so. And yet, how much of our time do we end up doing comprehensive documentation and focusing on processes and tools? It's sad, isn't it? When software developers have moved on from that to something much more agile. It's not that far removed from what Plowden was writing about back in the 60s, about a child-centered education. At the heart of the education process lies the child. One of the main tasks is to build on and strengthen children's intrinsic interests and learning and lead them to learn for themselves. Those of you who talked about extending learning out beyond the classroom, isn't that exactly what this captures? Start with the children's interest. Be agile. Be responsive to their interests. My friend Dan Bowen, now gone to Australia for at least a couple of years, shows this slide. So he went in and asked children, what is it you want in your ICT lesson? This is what they said. More photos, more story writing, more publishing. Okay, start using iPads, designing apps, designing games, making and sharing videos. Do the same exercise in your school. His learners may be different from your learners. What is it they'd like to learn about in the computing curriculum? Do that before you come up with a scheme of work. Ask them what they think. Briefly, because I'm running out of time, what are the themes? What's the structure you put? How do you create a framework in which to ensure you have breadth and balance? The easiest way is to look at what we have there in the program of study and to ensure you're giving a fair bite of the cake, cherry, whatever, to computer science, to information technology, to digital literacy. Ensure you have the right and proper attention paid to foundations, applications, and implications. Another approach is to look beyond the subject content to the sort of skills you want your learners to leave primary school having. And I'd say computational thinking ought to be on that list. But I'd also say an attention to the aesthetics of good design and the usability of good design ought to be there. I'd also want them to take a critical stance to digital content, to one another's work, to their own work as well, and to be willing to ask the why questions rather than merely the how questions. I'd also want them leaving primary school being responsible users of digital technology, not merely good at keeping themselves safe, important as that is, but being children who know that it's wrong to lie about your age in order to get a Facebook account, because that's using somebody else's computer without their permission. That actually being nice, being kind, being generous to other people online is a far better thing to do than being beastly to them online. That there is some content which we jolly well should not be downloading at the age of 11, or indeed at any age. And that whatever we do online stays online, that sense of responsibility. My friends at Computing at Schools, we put together a computer science curriculum. And when we were thinking about the taxonomy, the structure for that, these were the bullet points which we put into there, or these were the headings that we had there. If you take this approach, you'll have something which is very good at covering the computer science, but do remember to pay attention to the information technology and the digital literacy bit too. My friends Mark Dorling, Matthew Walker have done the progression through all of those strands there as their progression pathways document. I just leave this on screen for you to copy down the relevant details. Okay. In Switched On Computing, we took a rather different view. Yes, We have the new computer science bit, so there's a whole unit every year, on programming. There's also another unit where we look at some of the broader issues around computational thinking. And there's also that thing about how computer networks work, how the internet works, which is really important. We're getting into how to write HTML. Not because it says we have to teach that on the national curriculum, would that it did, but because that's a really important and interesting skill to have. And then there's stuff which is much more in information technology territory, about communicating and collaborating, about being creative, and about being productive. You know, PowerPoint, Microsoft Word, or their Google Drive equivalents, still jolly important skills to leave primary school having. Being able to code in Scratch, lovely, lovely thing to learn. Being able to put together a presentation, being able to word process an essay, that is going to be still kind of important as they move into secondary education. So what we did was not start from scratch, no pun intended, but start from the very successful switched on ICT, and I'd encourage you to do the same. Not so much start from switched on ICT, as start from your existing scheme of work for ICT. The units which are good, keep them. You're going to need to find some room for putting in more computer science and possibly more digital literacy. So get rid of the units which you were just repeating the same stuff. You know, there are only so many times you can tell children how to send text on a PowerPoint slide, really. There are. And find the space to add in the new units which cover the new stuff on the new program of study. If you want to get in touch, I'm around for the rest of the day. There's a Twittery thing on screen, email address. I blog occasionally. All of these slides are online if you want to click on the links. The printed version, as far as I can tell, the links don't work, but the ones on the slide deck will. Thank you all very much.